This question is from exercise 5B of Brian Jefferson's AQA M2 textbook. First, we write down the variables we know, the unstretched length of the string, which is A meters, and the modulus of elasticity, which is mg newtons. This is the amount of force required to stretch the string to double its natural length. The next stage is to draw a picture of the scenario we are dealing with. In this case, we are in a horizontal plane with two blocks of mass m and 2m. We're in a horizontal plane. The blocks are 3a meters away from one another and connected by an elastic string. We are going to start by viewing the problem using conservation of energy. Since nothing in the system is moving, it has no kinetic energy. And since we are not concerned with how far up these blocks are from the ground, the gravitational potential energy also doesn't come into play. The only energy we are dealing with in this initial state is the elastic potential energy, or EPE, of the system. The formula for EPE is the modulus of elasticity times the squared extension divided by 2 times the natural length of the string. Since we know that the extension of the string is 2a, which is just 3a minus a, we get 2a squared times, well, this is just mg divided by 2l is equal to the EPE. Now we can clear this up a little bit, so let's do 4a squared times mg over 2. Oh, we also know that L is A, so let's just change that now. Over 2A. So let's cancel these out. So that becomes a 2. Cancel that out. Get rid of that squared there. So now we know that the elastic potential energy is actually equal to 2 AmG. Now, since this is an isolated system and no external forces are being acted upon it, the energy, the EPE, will be conserved when the blocks are at this other point that the question talks about, when the string is slack, i.e. there is no elastic potential energy. This can all be only converted into kinetic energy, so that means that at that point 2AmG, our elastic potential energy, must be equal to the kinetic energy of this block, m, plus the kinetic energy of this block, 2m. The formula for kinetic energy, let's call it Ke, is equal to 1/2 times the mass times the velocity squared. So let's apply it. So 1/2 times m, let's call the velocity of m at this point v1 and the velocity of 2m at this point v2, times v1 squared, now this is the kinetic energy of m, plus 1/2 times 2m times v2 squared. Now let's do a little bit of algebra. So dividing everything by m gets rid of this. 2 times 1/2, you should know, cancels out. And now let's times everything by 2. So 4AG, that's to get rid of this half here, so we don't have any fractions, is equal to V1 squared plus 2V2 squared. Now, how can we simplify this further? Well, we've already looked at the problem from an energy standpoint, but what about if we look at it from a momentum standpoint? Since this is an isolated system, the momentums must add up. So, what's the momentum of this block? It's going to be the mass times V1, and that has to be equal to the momentum of this block. So it must be equal to 2m times V2. So let's do some cancelling. The mass goes out again. So now we know that V1 is equal to 2V2. Let's plug this back into our original formula. So now 4Ag is equal to 4, I just put that into here and squared it, V2 squared plus 2 V2 squared. This means that 4Ag is equal to 6 V2 squared, which means that 2 over 3 Ag, I just divided by 6, is equal to V2 squared, which means that V2 must be equal to the square root of 2 over 3 Ag. And now V1, due to our very simple expression over here, must just be equal to 2 times this. 2 times 2 over 3 Ag. So now, at this point, we've answered the main part of the question. Let's just get rid of this, some of this working. Alright, so now we want to take on the other part of the question, the first part of the question, which, if you remember, was to find where the two blocks collide. Let's start out by drawing our scenario again. So we are on a horizontal plane, and we had our two blocks, one of mass m and one of mass 2m. They were separated over 3a meters by an elastic string. In order to find where the blocks collide, we're going to look at this problem from a moment's perspective. And that's in order to find the center of mass of this system. Because since there's no external forces acting on the system, this shouldn't change. So let's try it. Let's take the moments about m, and let's call this the center of mass, which is x meters away from 2m. So first of all, the moment that m makes against 2m is 3am. That's about the pivot 2m. This must be equal to the center of mass, which will have, well, m plus 2m is 3m, times, and the horizontal distance to the pivot is x meters. So now if we divide through by 3m, we get a is equal to x. So the blocks will collide a meters from the initial starting point of 2m. Thank you for listening, and Please request questions that you want walkthroughs for in the comments. Thank you for listening.